Alright, hey everybody, thank you so much for tuning in to the bonus video. I think this one will actually go by pretty quickly, but we'll see. I shouldn't have said that. I didn't want to get your hopes up. But you already know how long this is going to take because you can see how long this video is, whereas I don't know how long this video is going to be. Anyways, I'm starting to spiral into this existential crisis. So let me take a deep breath and get back to it. So here, I haven't crunched any of these numbers yet. I have no idea what the answers are going to be, but I gave myself 2 goals. Well, technically 3 goals, maybe. So the first question, in case you can't read it, because I know that my handwriting is bad, and you may be watching this on a small screen, the question is, if you scored a 1250 on your SAT, what is your predicted GPA? We're going to say that's question number 1. And question number 2 is, how unusual is a GPA of 4.0? Is it more unusual than an SAT of 800? Okay, so that's a 2-part question. Excuse me, I have the hiccups. So here you can see, that was the last hiccup. No more hiccups. So here, this is the first data set. This is the SAT scores. And these are arbitrary. I made these up. I did not look them up. I don't know what the answers are. But the mean SAT score is 1,000, which seems high, and a standard deviation of 100. And then for GPA, we have a mean of 2.5 and a standard deviation of 0.5. So let's do the first one together. So if you scored 1250 on an SAT, what is your predicted GPA? Go ahead and pause this video and see if you can answer that solo by yourself. Go for it. Good luck. I believe in you. All right. So I'm going to assume that you paused it. So I'm going to go ahead and get started on it. The first thing that I want to do is I want to find my z-score. So remember that the z-score has a formula that looks like this: x minus mu over sigma. So if I'm going to plug that in here, I'm going to plug in my 1250 SAT, subtracted by the mean SAT, which is 1,000, divided by 100, that's the standard deviation, which gives me 250 over 100, which gives me 2.5. So that's a z-score of 2.5. Is my work done? Of course not. My work is not done. So next thing I need to do is to compare that with a GPA. Because what I've done now, by getting the z-score, is I found the standardized score. So I know that a SAT score of 1250 means that that is 2.5 standard deviations above the mean. So that is how to interpret that. So that's pretty good, right? I'm feeling pretty good about that SAT score. That's higher than my SAT score was whenever I applied to college by quite a bit. Here, so the way that we're going to do that is we're going to find a predicted x, and that predicted x is going to be z multiplied by sigma plus mu. So how do we get that? We're just going to plug all these values over here in, which is going to be x is going to be 2.5. So we're going to say 2.5 times sigma, which in this case is going to be 0.5. And we're going to add that to 2.5. Alright, so I got to break out my calculator for this. So that is going to be 2.5 times 0.5 is going to give me 1.25 plus 2.5 is going to give me 3.75. So that is my predicted GPA. If I had a SAT score of 1250, that would be my predicted GPA, which, hey, I said that that was higher than my SAT was in real life, and that was higher than my GPA was for my first year of college, too. Alright, so we answered number 1. Awesome. That felt way easier than it should. This trick, like I said, this trips up a lot of people whenever they take this on the exam or on quizzes, so feel free to reach out if you're getting a little bit stumped here. Let's do question number 2. So how unusual is a GPA of 4.0? Is it more unusual than an SAT score of 800? So what I'm going to do here is I'm going to try to section this off so I can write around this. Can I adjust my pen color? One second. I want to see if I can change the color of ink. Okay, great. So this will be for question number 2, which will be in blue. Alright, so how do I do this? How unusual is GPA of 4.0? Is it more unusual than an SAT of 800? Because I'm talking about unusualness, I'm talking about the probability of something, I'm going to refer to the empirical rule. And you may remember the empirical rule is this idea of 66, 95, 99.7. And basically that means that this is 1 standard deviation, 2 standard deviations, and 3 standard deviations. Plus and minus, so positive and negative. Alright, so let's sync these numbers into this idea. So what I'm going to do is I'm going to get the z-score for each of these, and then I'm going to compare those z-scores to the empirical rule. So how unusual is the GPA of 4.0? We just need to find the z-score. So we're going to refer back to this equation right here. So z is going to be equal to, so for 4.0, which is an amazing score, 4.0 minus 2.5 over 0.5, which is going to give me 1.5 divided by 0.5, which is going to give me a z-score of 3. So my GPA z-score is 3. Alright. If I want to find, now I want to find the z-score of 800, and I'm already looking at that 3, and I'm saying like, oh, that's really rare. That's in the top 1%, essentially. So we know that's a really rare score. Congratulations for making all A's. So the second is that more unusual than an SAT of 800? So we can plug that in. We can find that z-score. So I'm going to plug all that in. So I'm going to have an 800 here. It's going to be minus 1,000, because remember that is the mean, and we're going to be dividing that by 100, which gives me negative 200 over 100, which in other words simplified is negative 2. Alright, so I intentionally did this where there was one positive z-score and one negative z-score, because you can still compare them even if they are different polarities, different alignments. So a positive 3 would basically be, and I'm gonna draw this out on a normal curve, because I think that's always the best way to do these is to put it on a normal curve. So basically your normal curve looks something like this. So we got our mean right here, and then we have 1 standard deviation away from the mean, 2 standard deviations away from the mean, and 3 standard deviations away from the mean. And so what we're saying is that this GPA value is going to be way over here. That's where that 4.0 is whenever you make these scales equivalent. And that an SAT score is going to be over here. That's 800. So then the question is, which of those is more unusual? What we're going to say then is that the GPA of 4.0 is more unusual because we know that only about 1% of everyone got a value as extreme as a 4.0, and that roughly 95% of people got a z-score, roughly 5% got a z-score as extreme as plus or minus negative 2. So either an 800 or a 1200. Those would be equally unlikely to get. Just like, if we want to look at 4.0, what would be the equivalent of a 4.0 but negative? We can find that out by basically, yeah, let's do it. Why not? Let's do it. I mean, it'll be fun to do. So if I wanted to know what is the negative equivalent of a 4.0, I already know the z-score is positive 3. The way that I need to figure this out then is just plug in negative 3 while finding that observed value. So it would be negative 3, and I'm using this formula right here now, multiplied by sigma, which in this case for GPA is 0.5. And I'm going to add that to 2.5. So if I'm working with negative scores, it is a little bit different because, as you can see, negative 3 times 0.5 is going to be negative 1.5, and I'm going to add that to 2.5, which is going to give me 1.0. So basically, if I had What is a value as extreme as a GPA of 4.0? A GPA of 1.0. They're equally unlikely. They're just in different directions. I think that's pretty much it. If you have any questions about this, or if you want me to give you another example so you can test your strength on this, just let me know, and I'll be very happy to help you. Otherwise, have a great day, and let me know if you need anything. Bye.